Okay, this is the Math 2460 Zoom meeting for Friday, November 6th. We have a participant. Can't see your name because I'm on camera. I have the camera going. You want to tell me who you are?
It's Mark.
Okay. We may have other people join us here. Yes, we do. We have somebody else. You want to identify yourself? I've got Mark here. Who else have I got? Don't want to, either can't hear me or is trying. And you have any questions today?
I know we were last Zoom meeting, we were working on, it was 9, was it 9.9 or 9.8? I don't remember the numbers, but you said that there were some more complicated ones that took a lot longer.
That was the IOC, this interval of convergence. Did you want to see an example of those?
Yeah, please, if you don't mind.
All right. Any one in particular?
I remember you were saying how there were some that were pretty long.
Yeah, it's hard to tell at the beginning.
I remember when you was it there? Was it in the, I gotta check I think it was in the 9 through 14 section you pointed out.
Okay. Now those are radius of convergence and those are half problems. The easiest ones are stating where you're centered around. That's just figuring out what'll make your X term 0. So that's the easiest thing. So number 5, you're centered around 0 because it's a straight X, and number 7, you're centered around 2. Because 2 minus 2 would be 0.
Okay. I don't remember which ones it was though. Was it the 15 through 20?
The 15 down through here, yeah, these are the real man problems. The full interval.
Yeah, could we do one of those?
What makes it a real man is the check for convergence at the endpoints. That is what really kind of extends it out. You want to try something like 27 maybe?
Sure. Yep.
Okay. We'll be here a while. Start on the top of a clean sheet of paper like I am. It's off page 658. Find IOC for -1 to the n plus 1 to the n plus 1 over n plus 1. I know that reads, you want to see a few pieces written out, or because otherwise it does read like real gibberish.
Yeah.
All right, well, you just again start with n equals 0. So that's going to give you a negative. You have an x minus 1 to the 1 over 1. All right, then if you have n equal 1, that's going to give you a positive, because 1 plus 1 will be 2 there, so -1 squared, even power, that'll be positive. X minus 1 squared over 2. And if you want to see one more, n equal 2, that should turn back negative, because you'd be at 3 there. X minus 1, 2 plus 1 is the third, over 2 plus 1 is 3. So it's an infinite series. It looks like that. It's centered at 1. And there's some function this is equal to, but they're not going to tell you that. We don't really get into that until 9.9. That's coming attractions for next week. What is this equal to? What is this equal to? 9.9, coming attractions. Please stay tuned. I know the suspense must be killing you, but try to control yourself. Yes. All right, are we ready to find our IOC?
Yes.
Okay, that means you want ratio test. Remember, IOC, and I've frozen. Can I come, man, 8 o'clock worked, okay, good. IOC stands, you remember that stands for interval of convergence? Interval of convergence. It basically is identical to domain. It's equal to your domain. They call it the domain in college algebra. The set of x's for which this will converge. So you find this with a ratio test, and you're taking limit as n goes to infinity. I'll write it out real slow, full ratio test. That's why they had you do those problems back in 9-6. Okay, again, ignore this. Sign switching, so ignore it. So we're going to have x minus 1 to the n plus 1 plus 1 over n plus 1 plus 1. I'll write it out. That is your an plus 1. Any questions about that? How many people we got now? We up to a few people. We're up to 4 participants. Very good. All right. You see where I'm getting an plus 1?
Yeah.
So now you're going to divide it by the an. Well, that's just what's here. X minus 1 to the n plus 1 over n plus 1. I know this can get confusing, but the an is what's given. It just happens to be given n plus 1s. And then an plus 1, you plug in n plus 1, which is going to give you n plus 2s actually in the next step. So any questions getting this far?
Nope.
Okay. So that's going to give you limit as n goes to infinity of x minus 1 to the n plus 2 over n plus 2. If you want to know level 1, level 2, then I'm going to multiply by this flipped. So that's going to multiply by n plus 1 over x minus 1 to the n plus 1. Notice the absolute values are important because that's what's going to spread out my interval at the end. All right, what I'm going to do is collect term. I'm going to collect the x minus 1 terms, collect the n plus 1 over the n plus 2. I'm going to have x minus 1 to the n. Remember how you can spread out a sum in the exponent? Times x minus 1 squared. I'm going to divide that by x minus 1 to the n, and then x minus 1 to the 1. And I'm going to collect over here n plus 1 over n plus 2. Pause for station identification. There can be a lot of gibberish in these problems. Have we lost anybody?
Nope.
Okay, can you tell? See, that's the reason for spreading these things out, that you can isolate what cancels. Those two cancel. So I'll go to another page. Keep it on the screen. All right, equals infinity. Can you tell that cancels, leaves you in x minus 1. Can you do the L'Hopital rule in your head? You're getting, infinity over infinity directly for the n. So you do a derivative, you get 1 over 1, derivative here is 1, derivative here is 1. And I wind up with absolute value of x minus 1. Questions about that? Don't hear anything. Is everybody so awestruck no one can speak?
Yep.
Okay. Is this old hat now?
Yeah. Yeah.
Okay, so that limit works out 1, and we want to see the x doesn't matter. It survives just like a number would, because you only care about the limit as n, and so there's no n's here, and you wind up with just the x minus 1, which we are going to set less than 1 for convergence. For convergence. So I want to solve absolute value of x minus 1 less than 1. And that means -1 is less than x minus 1, which is less than 1. This blob here has got to lie between the ones. Reaching back to your college algebra. And then you can add 1 here, add 1 here, add 1 here, and I wind up with 0 less than x less than 2. I call that the nominal IOC. At this point, I now know to converge, the x's are between 0 and 2. I know the radius of convergence would still be 1, but they didn't ask for the radius of convergence. But from this, I can tell the radius of convergence, but it didn't ask for it. All right, before we go on, see, we're only about halfway done. So before we go on, any questions getting this far?
Nope, I think I'm good.
Okay. So we've written strict less thans again because that was the condition to converge on the ratio test. But I really haven't nailed down whether 0 works or 2 work. Do 0 or 2 work? That's called checking endpoints. I know you're dying to know. Remember, do I need to write down the 4 cases again? I wrote it down Tuesday, right, real fast at the end. Remember there's 4 cases. If it's brackets, both work. If it's parentheses there, 2 works. If it's bracket here, parentheses here, I'm sorry, parentheses there, 0 works. And if neither work, there's parentheses in both spots. Neither work. I don't know if y'all remember this from Tuesday. Does this make any sense?
Yeah, I remember that.
Okay. So that's where we got to charge in. We've got to sub in x equals 0, check, and sub in x equals 2 and check. The thing is, you can't really tell just from subbing in. I'm subbing them into the original, this. And you can't tell. You've got to write it out. You must write out the pieces. That's what makes these so long to tell. And usually you can tell what happens. If it's just going to get bigger and bigger, it diverges. And if you recognize something like an alternating harmonic that converges, then it converges. Are we ready to charge in?
Yep.
Okay. The order you do it doesn't matter. I guess I'll start with 0. So I'm checking x equals 0. All right, let me see if I can bring back the original. I'm subbing in sum n equals 0 to infinity. Now see, it's x equals 0. I get a -1 to the n plus 1, 0 for the x, 0 minus 1 to the n plus 1, all over n plus 1. So that's going to give me -1 to the n plus 1, another -1 to the n plus 1, over an n plus 1. Do you recognize this is harmonic? It's first power. We're getting a harmonic here. Now, if you're really slick with your algebra, you could combine these two, but I never do that. I just start writing out pieces. If the signs are the same, diverges. Signs alternate, converges. So I'm just going to start writing in the zero and his 0 piece and his 1 piece and his 2 and just write out 2, 3 pieces, and I should be able to tell. So the n equals 0 piece. See, I'm going to get a 0 for n and 0 for n. Both of these are going to be negative. That turns positive. So I'm going to get a positive 1 over 1. The n equals 1 piece. Well, that's going to make both of these positive. So 1 plus 1 is 2, 1 plus 1 is 2. So negative 1 squared, negative 1 squared, both are positive times positive. So that's a positive 1/2. Well, that pretty much tells you the signs are going to be the same, but I'll write out one more. All right, so if I go n equals 2, again, both are negative, but that turns positive, and then 2 plus 1 is 3. So can you tell this is a pretty much a straight harmonic, all positive signs? So it what? It
Diverges.
diverges. X equals 0, not in IOC, not in the interval of convergence. Are we ready for, in other words, it's going to look like parentheses with a 0. 2, but is that a bracket or parentheses? The suspense is killing me. Are we ready to check?
Yep.
So, check. X equals 2. And again, that's the spot it got plugged into. Now we just change the 0 to a 2. To infinity, minus 1 to the n plus 1, 2 minus 1 to the n plus 1. Unless you are a real genius and can tell from that, I can't. Who knows? That's why if you write out pieces and look for signs, or look for your clues, this is going to be a sum of n equals 0 to infinity to the n plus 1, 1 to the n plus 1 over n plus 1. So again, do the signs alternate here, or are they the same? Let's find out. So n equals 0. You're going to get a negative there because n is 0. It's a negative 1 to the 1. So this is negative. This is positive. So that's overall negative 1 over 1. So first piece is negative. All right. Plus, let's find out n equals 1. Well, that's going to be positive, and that's going to be positive. And 1 plus 1 down here is 2. That's a positive. Looks like the signs are what?
Changing.
Yeah, changing, alternating. But I like to write out one more just to nail it down. So n is 2. See, that's going to be a third power. So there's negative. This is positive. So that's a negative again. And you're at 3. Yep. Alternating signs. This converges.
So 2 is going to be in brackets.
2 is a bracket. Need 2 in a bracket. Yep. See, this is very technical. Answer. IOC. 0, 2, numbers between 0 and 2, but the 0 didn't work, the 2 did. Now, anybody want to run an idiot check and have me check the answer in the back of the book and see if I'm an idiot? I would be thrilled. Or do we believe? Looks like some people need convincing. Let's see. Never do these in advance. I make all my mistakes in front of you in real time. It was 9/8. It was 27, wasn't it? Yeah, 9/8, 27. There we are. I don't know if you can see it. 0, 2, zeros in parentheses, 2 in the bracket. See what you get for an answer in the back of the book? And look how many pages. I took 3 pages getting there. These problems are a thrill.
Fun.
Yes. Kind of makes you appreciate the last section. Did you find the Taylor and Maclaurin polynomials a little more straightforward?
Yeah.
Yeah, see, that took 20 minutes. That's the only problem we've worked so far. It took 20 minutes. I'm getting the mood of the Zoom session here to put a whole bunch of those on the test.
No, thank you.
Never get the mood of the room, right? The mood of the Zoom, right? And go. What else can we show you?
I don't know.
You dying to see another one of those?
Is there one that's like easier, like less time consuming?
Not really.
Okay, yeah, let's do another one then. Sure, why not?
You want another one?
Yeah.
What about 23?
Sure. I don't know what it is, but yeah, that works.
Okay, page 658. Find 4. X to the n over 6 to the n. All right, let's see if we can do a ratio test on this. We could, can I speed? I showed you all the steps. That's what made the last one so long, just trying to remind you what a ratio test was. Can we speed it up?
Yeah.
All right, so you see, here's how I'd speed up, just to remind you, we're plugging into an plus 1 over an. So that would take limit as n goes to infinity. The an plus 1 would be x to the n plus 1 over 6 to the n plus 1. Now you see I'm going to divide by an, which means I multiply by the flip, 6 to the n over x to the n. Is that too fast?
Nope, it's all good.
Okay, an plus 1 times an flipped. All right, well then again, collecting x to the n times x to the 1 here, collect the x to the n under it. And you have 6 to the n here, and you have 6 to the n times 6 to the 1. I'm just writing in the ones just for clarity. You don't technically have to write the ones. Just for clarity, you're going 6 to this, 6 to that, x to this, x to that. See the cancels? X to the n's, 6 to the n's. There's nothing left with an n. So I wind up with absolute value of x over 6. So this one's working out a little shorter. And so you want to set less than 1. So -1 is less than x over 6, which is less than 1. In other words, whatever this blob is, it winds up between the ones, between -1 and 1. And again, at this stage, we use strict less than's because that is the condition on the ratio test. Now, y'all remember your college algebra, what to do for this? That's where things vary. You have to, however this works out, you're supposed to know what to do to get back to a plane X. You see what to do on this one?
Multiply by 6.
Multiply by the 6. -6 less than x, which is less than 6. That is the nominal IOC. It's between -6 and 6. But again, we got to nail down the 4 cases. Do either of them work? Are we ready to charge into that?
Yep.
Okay, I guess I'll check -6 first. Check. -6. 1 to infinity. -1 to the n plus 1. -6 to the n over 6 to the n. Now, what I like to see, you see what I've done? I've just plugged in -6 for that x. Now, you see how both of these are to the n? I'll write out more steps here trying to make it more obvious. You can go -1 to the n plus 1, big parentheses, -6 over 6, all to the n. See, if each one is to an n power, then I can collect them underneath, all to the n power. And a -6 over 6 is what? A -1, right?
1, yeah.
N equals 1. So I go out and do that. -1 to the n plus 1 times a -1 to the n. Again, if you were really slick, you can add the n's here, -1 to a 2n plus 1. I'd never do that. I just start writing out pieces. And notice this is not harmonic. There's no n on the bottom. Not harmonic here. So if I write out some pieces, the n is 1 piece. This is going to be positive. This will be negative. I start with -1. It's n equals 1 piece. The n equal 2 piece. See, that'll be negative. This will be positive. They're all negative. Can you tell they're all negative? N equals 3. Individually they swap, but still one's negative, one's positive, making it overall negative. This will be positive. This will be negative. See how they're all negatives?
So it's converging. Oh, wait, no.
Well, think about it.
It's diverging.
It's diverging. You're just adding -1 to infinity, right? Divergence.
Yeah.
So x equals -6 does not work. Are we ready to check x equals 6? X equals 6 to infinity, -1 to the n plus 1, 6 to the n over 6 to the n. If you know what I'm plugging in x equals 6 right there. Now, if you want to see how 6 to the n, 6, you could cancel them. That's, you can play it that way. That's fine. I never do. Can you see you're going to get sum n equals 1 to infinity, -1 to the n plus 1, and a +1 to the n? 6 over 6 all to the n. So
Yeah.
Plug in n equals 1. See this positive, positive. I'm going to get 1. N equal 2. I get a -2 plus 1 is 3 there. So it's odd power. Negative times positive, that's a -1. N equals 3. See, once again, they're swapping. No, actually, that's back to positive. They're alternating signs. 1 and n equal 4. So you get a 5th power. So that's -1. Plus 1, -1, plus 1, negative. All right, you tell me, converge or diverge?
1 converges. Wait, yeah, converges because it's alternating signs.
That alternating signs worked when it was harmonic and you had 1 over n. But you see, these are straight ones. There's no fraction.
Oh.
Yeah, it's very easy to get this confused. So this just, you can add and subtract 1 forever. Depending on where you stop, you wind up with a 1 or you might wind up with a 0. It never converges on a single number. So this diverges. In effect, it bobs up and down between 1 and 0 if you summed it up. About where you stop the sum, you might get a 1. If you stop at some other place, everything might cancel, you get a 0. The sum is bobbing between 1 and 0. And so this diverges. So IOC, -6, 6, both with parentheses, neither work. Questions about that? Deafening silence. This is so awestruck, nobody can speak.
Yep, basically.
Okay. Anybody want to, we're only 30 minutes in. Does anybody want to see anything from 9-7, a Taylor polynomial or a Maclaurin polynomial?
Yeah, could we do, which was it Taylor, the one without the zeros?
Yes.
Yeah, could we do a Taylor?
Have one in particular?
No, I can't think of any off the top of my head.
Okay, here's the section in the book. Only thing a little, it's really not that hard. The only thing that's confusing, people get the C confused with the N confused. That's the only thing you really got to keep straight. C is what you're centered around. You're going X minus whatever the C is, and you're taking it out to like second power and 29, third power and 30. This is the power you're taking it out to, the nth power. Anyone in particular?
I don't know. Let's do 31.
31? Okay.
Yeah.
$6.49. F of X is equal to log of X. The N is 4 and the C is 2. All right, I'm going to plug in, I'm going to write it out generally with the C's. You would start with F of C, F prime of C, X minus C, F double prime of C over 2 factorial X minus C squared, triple prime of C over 3 factorial X minus C cubed, fourth of C over 4 factorial X minus C to the 4. You see why I'm stopping at 4? That's the fourth power. And the C, that's what you're centered around. Anybody want to see the gibberish in the book where I'm getting this from?
No, I remember that from last.
I'm going to sub in C as 2 before I make my table. So basically, a log X is F of 2, F prime of 2, X minus 2, F double prime of 2 over 2 factorial X minus 2 squared, F triple prime of 2 over 3 factorial X minus 2 cubed. Finally, fourth derivative of 2 over 4 factorial X minus 2 to the 4th. I know it takes a little more work writing it out, but to me it's worth the effort because then when I make my table, I know exactly where I'm plugging and chugging. Okay, are we ready to charge in? See, I'm gonna make a table. You take a derivative, plug in 2. All right, so I start with the f of x, and that's a log x, and f of 2, see, that'll be the first piece right here. I'm just going to write a log 2. I know that's a decimal. I'm just going to leave it log 2. So now I take a derivative, 1 over x, plug in 2, 1/2. And I just keep going down until I get to a fourth derivative. F double prime of x, probably helpful if I wrote that x minus 1, negative x to the negative 2. That'll be a negative 1 over x squared. F double prime of 2, negative 1 over 2 squared, negative 1/4. Should I pause for station identification?
I'm good up to this point.
Anybody else want to ask anything? 2 more rows to go, 2 more derivatives. F triple prime of x, you'll have a positive 2x to the negative 3. You want to write that 2 over x cubed. F triple prime of 2 is then 2 over 2 cubed. That's 2 over 8. That's a positive 1/4. One more to go. Fourth of x would be a negative 6, x to the negative 4. Negative 6 over x to the 4th. And plug in a 2. Negative 6 over 2 to the 4th. Negative 6 over 16, which is negative 3/8. I am now ready to plug and chug. Any questions before I plug and chug? It really is just a matter of replacing these f of 2's. F prime of 2, just plugging in right here, right here, right here, right here, right here. And then just you're copying out the rest of it. It's really that easy. If I can leave that on the screen while I do it, if I can or not. All right, so my log of x then is equal to f of 2 is log 2. Goes right here. Plus my f prime of 2 was 1/2. X minus 2. My 1/2 x minus 2 plus, roll up, my f double prime of 2 was a negative 1/4. 2 factorial x minus 2 squared. That's this piece, negative 1/4 over 2 factorial x minus 2 squared plus f triple prime of 2, that was a 1/4. X minus 2 to the 3rd. Keep this, and then finally my f fourth of 2, negative 3/8 over 4 factorial x minus 2 to the 3rd. Now that may or may not be the answer in the book. Book may simplify these coefficients. This is pretty easy since this is 2, so you get a negative 1/8 there. 4 would come down here. You did, I think, 24 here, and then however that worked out. Anybody want me to check the book and see if they worked out those coefficients?
Sure, if you don't mind.
Okay.
Yeah, because I haven't checked out the WebAssign. Is that what they're expecting us to write? I don't know.
No, I have no idea. I didn't write the program. So if you could try entering something like this with the factorials, if you can figure out how to do that. If that doesn't work, then you might want to simplify the coefficients. Yeah, that drives me nuts too.
Yeah, that's what like my least favorite thing about WebAssign is.
Yeah, you wind up playing a game. Let's see if we can make the computer happy today.
Yeah.
And it just kind of detracts from the learning the math. Let's see. This was 20. This is 31, 9, 7, 31. Okay, let's see. Yeah, they worked out the coefficient, at least in the book here. All right, here's 9, 7. flip it over to 31 and okay, you can see the log 2 matches. Point to it. The log 2 matches. I got the 1/2, the x minus 2. And then, yeah, the next one's 1/8, next one's 1 over 24, next one's 1 over 64. Let's see if I can show you that. Yeah, if you can see, you're getting a negative 1/4 times 1 over 2, which is your negative 1/8. So this works out negative 1/8. That's right. Now this one will work out 1/4. See, that's over 1 times 1 over 3 times 2 times 1 over 3 factorial. So yeah, there's your 1 over 24. And this is 4 times 3 times 2 times 1. So that's negative 3/8 times 1 over 4 times 3 times 2 times 1. Your 3's cancel here if you want to simplify it out. So there's 32 times 2. That's negative 1 over 64. So yeah, there's your log x. There's your log 2, 1/2 x minus 2. Minus 1/8 x minus 2 squared. This one worked out plus 1 over 24 x minus 2 cubed. And that worked out a negative 1 over 64 x minus 2 to the, I wrote third here again, my fault, that's 4th power. Well, you guys let me get away with murder. My fault, that's a 4th power. So I don't know if you can tell, but there's your plus 1 over 24, minus 1/8, and minus 1 over 64. Did that convince anybody or only me?
Oh, so I just checked the WebAssign. Oh yeah, so it's looking like you do need to write out the entire thing like that.
Okay.
Yeah, it's probably, I'm assuming they're gonna ask to simplify it. That's what I would guess.
Okay. It's not that hard. It's just, again, more work. It just makes the problems longer.
Yeah.
In class, when people are writing these things out, I pretty much accept to write here. Just let you fill in the coefficients above the factorials. Figuring the rest is just arithmetic. This is calculus class, not arithmetic class, and the calculus is done when you fill in the pieces like that. The rest of it's just arithmetic.
Yeah.
Did y'all want to see any others? We're at almost 45 minutes.
I think I'm good for today.
All right. Do we have still any other participants? Yeah, we've still got 3 total participants. And y'all want to speak up or say anything? Ask for another problem? Next week, we do 9-9 and 9-10. 9-9 will be a bit of a pit. 9-10 won't be. 9-10 is a repeat of 9-7. So 9-10 will be pretty simple. If you've learned 9-7, it's just a repeat. 9-9 will be a bit of a pit. And then we'll have the 10. We won't have a quiz next week. We'll have the test on chapter 9. Then after that, we do easy chapter 10, and doggone, you get out your crying towels because our precious time will be over. Hang in there.
Then on to Calc 3.
Yeah, on to Calc 3, which I don't know if you're going to do online or not. I have no idea. Anything else, or are we ready to end the meeting?
I think I'm good.
All right, anybody else want to say anything? All right, if not, I guess we'll go ahead and end the meeting then. Thank you all for coming out on a Friday morning. Really appreciate it.
Thank you.
Thank you.